Yeah. Good afternoon to all, dear students. Today we are going to start a new unit, which is diffraction. So diffraction is one of the unit in optics class, optics course, which is very useful in determining the structure of the material. As we discussed, interference equally, diffraction also play a very important role in structural determination of the material. As we all know that XRD, X-ray diffraction, is the one tool which we use to see the factual structure of your body parts, which also use X-ray diffraction used to characterize the material, nanotechnology, all the material industry. It's a very great tool. So not only XRD, not only X-ray diffraction, electron diffraction, neutron diffraction also equally play a very important role. Okay. Uh, so diffractions, basically, there are two types. Okay, Fresnel diffraction, Fraunhofer diffraction. Today, I'm going to share the slides before we, wait, give me 1 second to share the, yes, here is the slide. All right. Right. So, uh, so diffraction. This is the actually this is third unit. It's not a unit two. I mean we have completed actually unit one and unit two. We already completed the unit one and unit two. Unit one is the basic description of the uh, waves, like phase path difference, phase difference, wave properties, all this we did. Then we move to interference. So this is the third unit, diffraction. Next unit is the last unit. Okay. So you have to be careful. You have to note down the important points. So introduction. What is actually are you able to see the slide? Any difficulty?
No, sir, it's clear.
Great. Yeah. Introduction for the diffraction. Introduction for the diffraction. Yes. Wow. Great. So diffraction. What is actually diffraction? It's a model for the light. It's one of the main characteristic of the light. As we did interference 1, diffraction 2, polarization 3. These three are the main properties of light and can be used in many applications. Diffraction can be described only with a wave model of for the light. So what is actually a diffraction pattern occurs when a light from from an aperture is allowed to fall on a screen. So if someone asks you what is diffraction, you can simply lay spreading of light when the light incident on a aperture or a slit. So you can have the fringes, bright and dark fringes, or bending of light, that is also diffraction. So when can be born? So if you can observe anywhere, can we see the diffraction in our home? Where can we see that? Does anybody knows where can we see the bending of light?
From light.
Yes, but yeah, from light, yes. Suppose you have a two rooms in your home. When you turn on the lights in one room, you can also see the light in other room. There is a spreading of light in another room due to the door window, right? So that is a spreading of light due to the aperture or slit or any obstacle is called diffraction. Diffraction is a phenomenon which can be seen only when light incident on any slit, aperture, you have the diffraction. It's like a spread, bending. Some simple definition is bending of light by aperture or bending of light. How can it bend? Definitely, you need to expose the light on any slit. You need to expose the light on any aperture. You need to expose the light any small window, right? So the other room also you can able to see the light image, a light. So that is the introduction about the. You can see here a couple of example I posted here. In case of blade, in case of sun, in case of here there is a rainbow colors are there, different colors are there. Those are the shadows you can see. So with the there is a building on top of that, so sunlight actually exposed in all directions. See? So because of that, the building edge, there is an edge on top of the building. So because of that, there is a light bended actually. Even similarly, lot of in case of blade also you can see lot of edges are there for the blade. So because of that, there is a light is you can also see on the around the blade there are fringes, dark, bright, dark, bright, dark, bright. Okay. Here also you can see different colors actually. Why we can see different color? Because each color has a when the white light incident on the slit, due to that it banded it spreaded light into various color because white light has all colors. So you can see here when a narrow peak or obstacle, narrow opaque obstacle or aperture we call it. Aperture is a small window. We placed between a source of light and screen. మీరు ఏం చేస్తారంటే ఈ యొక్క అపార్చర్ని ఇప్పుడు సోలార్ లైట్ ఉంది రైట్ సన్ లైట్ అక్కడ ఉంది బయట మనకి అంటే రెండింటికి మధ్యలో ఇఫ్ యూ కెన్ ఏబుల్ టు ప్లేస్ ఏ అపర్చర్ ఆర్ అబ్స్టాకిల్ మనకు ఈ యొక్క డైఫ్రాక్షన్ అనేది కనిపిస్తూ ఉంటుంది. So light bend around the corner of the aperture. This encroachment of light is called diffraction. Is it clear? So just simple definition you can see. When a narrow opaque obstacle or aperture be placed between the source of light and the screen, the light, what happened in that case? Light bend around the corner of aperture. And this phenomenon or this fringes, we call it as a diffraction. For the diffraction, size of the aperture is small. We have to keep a small aperture or slit, small slit unte, we can have the good fringes. As far why? The question you can ask me, sir, enduku chinnaga unchala sir? Why we need to keep the small aperture? The question is, the answer for this, to have the diffraction pattern like this or like this, the condition is the wavelength of the light must be close to the aperture size. అంటే ఇప్పుడు రెడ్ లైట్ తీసుకుంటే దాని వేవ్ లెంత్కి ఈక్వల్ అయిన అపార్చర్ అంటే ఆ స్ప్లిట్ స్లైడ్ ఉంటేనే మనకు ఫ్రింజెస్ కనిపిస్తాయి. అలా అని చెప్పి సార్ నాకు పెద్ద డోర్ ఓపెన్ చేశాను, ఐ జస్ట్ టర్న్ ఆన్ ద లైట్ ఇన్ వన్ రూమ్, ఐ డెంట్ సీ ఎనీ diffraction in another room. You may see the spreading of light, but you may not see exactly fringes like this. Sometimes if you make a small wall from the door, you may see that actually, like this. So there is a, but if you can keep the small size only, you can able to see the diffraction. Okay. Here you can see the what is the diffraction also. As a result of diffraction, the edges of the shadow are not sharp. but the intensity is distributed in a certain way depend upon the nature of the aperture. ఇక్కడ చూసినట్టయితే మనకు what results we got from the diffraction. Wherever you see the edge, you can able to see in the water also. If you drop an object, there is a kind of pattern you can able to see, right? Diffraction pattern. Here also lights, see how lights are like due to diffraction only can able to see these different colors lights. So when light మనకు మూవ్ అవుతున్నట్టుగా అనిపిస్తుంది, but they don't move really, right? ఇప్పుడు మనకు when you keep the designing light, చిన్న లైట్ ఫంక్షన్ హాల్లో పెడితే అవన్నీ మూవ్ అవుతున్నా ఉంటాయి, but they don't move actually, right? Lights, they are you able to, did you see the in day to day life sometimes when you in the functions, the lights actually you can we thought that they move actually from one place to other place. Usually they don't move, right? Is it clear? It's because of diffraction. Amulya, is it clear? సో చూసావా అవి మనకు కనిపిస్తాయి ఇట్లా అంటే మూవ్ అవుతున్నట్టుగా ఫంక్షన్స్లో లైట్స్ మూవ్ అవ్వడము కానీ డిడ్ యూ సీ దట్?
Yes, sir. From disco lights, we can
Yeah,
see
yeah,
that.
kind of, correct. So all these actually it's because of the diffraction. So now I hope you understand the concept of diffraction. I also posted here two cases of diffraction. Single slit diffraction, the diffraction occurring due to single slit and double slit. But what a image, what a animation. Did you feel anything here? It's like wonderful, right?
Yes,
We,
sir.
we can create this, which is in our hand. You can able to create this. I can see so wow, great music. All this is you can create in designing. It is possible actually. So here you can see how come, wow, up to here it's a parallel, but when this plane of light incident in a small slit, and after that it becomes like a circular shape. It's like a one time dark, the other time white, bright, dark, bright, dark, bright, dark. It's like a diffraction fringes. Here also you can see that if you have it's a different design you can see here. Here you have a circular shape, but here when you keep the two slits, it's like an interference also going on here. It's a double, when you keep the double slit, it's like a mixed effect. Diffraction and interference, because for interference you need two waves. For diffraction, one wave is enough. So you have the mixed effect here. Okay, that's good. Then again, I just put a picture here, like in a realistic way, high-end principle. So how we got this diffraction and interference? Initially, Huygens proposed that the light as a wave behavior. Newton proposed it's a particle behavior, right? So Young proved that light as a wave behavior, right? So every particle, every particle on every point you can think about every point on the wave front, right? Which is act like a source for the next wave. Every point on the any wavefront you take it, and every point which act like a source for the next wave. Okay, so according to Huygens principle, which require the waves spread out after they pass through the slit. This spreading out of light, this is actually diffraction. Spreading of light from the initial line of travel is called diffraction. So many ways, the way you can define the diffraction in many ways. When you expose the light on any slit, the spreading of light is called diffraction. Right? In general, diffraction occurs when the wave passes through a small opening around the obstacle by a sharp edges. The condition, as I mentioned, why we need a small opening? Because it should have the probable equal to the wavelength of the light that you expose. If you are exposing red light, the opening size of should be the wavelength. Suppose with 7,000 nanometers, 7,000 angstrom units. So this you have to convert into the meter and or millimeter and make it such a small hole, right? You know how it's very small, right? It's not like a big. You can feel it. 7,000 into 10 to the power of minus 8 centimeter minus 10. So if I keep centimeters, let's say minus 8, right? So this is going to be 7 into 10 to the power of minus 5 centimeters. If I want to keep again millimeters, you just need to, again it's going to be, I think, 7 to the 10 to the power of minus 4, which is actually, very small, very, very small. Okay? And which is, it's not easy. That is the reason visible light cannot produce the diffraction. I mean, it can produce, but we cannot able to see that. It's very, 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 usually you always you go for the X-rays for the diffraction, right? We didn't see that you can able to see the diffraction with the visible light. So with the 4,000 to the 7,000 wavelength light, we cannot use this to have, because making such a small hole, which is impossible, right? Diffraction is possible because it's close to the centimeters in case of X-rays. Okay, we have done, right, UV rays, IR rays, all these things, visible spectrum, ultraviolet, IR, right? High energy rays are this side, X-rays, right? And this side is microwaves, radio waves, etc. So now I hope it's clear why we don't see the diffraction pattern with the visible light in our house. అంటే కనిపించదు మనకు పెద్దగా ఆ లైట్ ఆ కలర్స్. Okay, so a single slit placed between the distance light source and a screen produces the diffraction. As I again repeating this, remember that single slit, you can make double slit and single slit, but single slit should be placed. Here you have a source and you have a screen here. Where you keep here, so what you have to place single slit like this. Then you have the diffraction pattern. Then you have the diffraction pattern. Okay, very nice. So where we keep the slit in case of diffraction? Where we keep the slit in case of diffraction? It should placed between the source of light and the screen. Where we place the screen single slit to have the diffraction, we place the between the source and screen, and it will have a broad intense central band. The central band will have a flanked by a series of narrower, less intense second bands called secondary maxima. The central band will also be flanked by a series of black and white, and that is called minimum. So we have a dark bands and bright bands. As we have seen in the previous slide, you have the dark like this, right? Dark and bright bands. Okay. So you can also see here, beta, the results of single slit cannot be explained by geometrical optics. It cannot be explained by a geometrical, optics. In this case, without diffraction, you can able to see like this, with the diffraction like this. So geometrical optics would say that light, say, traveling in a straight line, should cast a sharp image of the slit on the screen. So this you can see clearly here without diffraction. See, here it just goes straight. Here there is a, because of the a small size of the slit, there is a diffraction pattern. You can able to see that. So if you have a slit big size, you cannot see the diffraction. So very important question, 4 marks question. So I don't want to go further after this. I'll just stop today because I don't want to, just I'll just upload it to the YouTube. Maybe other people can see that whenever they get a time. Uh, so yes. So what are the? I mean, how many types of diffraction? What are the types of diffraction? So there are two types of diffraction. How many types of diffraction? There are two types of diffraction. What are they? Fresnel diffraction, Fraunhofer diffraction. There are how many types of diffraction? I mean, I'm not asking the types of diffraction. There are other things actually. I mean, the persons, according to the persons I'm talking about. Types of diffraction according to the persons. I mean, there are different opinions of these two people. There are different opinions for the Fresnel and Fraunhofer. So he considered in different way, the Fraunhofer considered in different way, and then the Fresnel. But if I ask general diffraction type, X-ray diffraction, electron diffraction, neutron diffraction, those are the things different. Okay, depending upon the situation, we use the neutron diffraction, electron diffraction, X-ray diffraction. Most of the cases, X-ray diffraction can be useful in day-to-day life. But when you want to go behind that, like electron atomic size wise, we go for electron diffraction. When you want to go for nucleus related, neutron diffraction. Okay. So a lot of stuff is going on now. So this is very important question for the, I mean, competitive exam purpose definitely useful. Where can we place the slate? What are the, even the bits from here also they will come. So let us differentiate Fresnel diffraction. What is Fresnel actually? What is a Fraunhofer? What they have opinion about the diffraction. In Fresnel diffraction, he used the cylindrical wave fronts. He used the cylindrical wave fronts. You keep in the every point you keep in the brain and store in your memory card of your brain. Oh, nice. Fresnel used the cylindrical. Wonderful. Then Howard, this guy, and he uses the plane wave front. So Fresnel used the cylindrical wave front, whereas Fraunhofer used the planar wave fronts and the plane waves we just said. Okay, here he used the cylindrical type. You can think about how the cylindrical types, right? It's like this, kind of like close to spherical actually, I would say, cylindrical or spherical. The next point is the source of screen. Source of screen. No, I think this is something different. Source and screen, not source of screen. Source and screen are placed at a infinite distances from the obstacle. Change the sentence. The source of light and screen are placed where, tell me, at a infinite distance from the slit. Wow. So if slit is there and the light and image should be, it's like infinite distance. Sir, how come they place infinite? It should be like a long distance. Think about it. Okay? Infinity means it should be very long. Wow, nice. The next different here, it's a finite distance. Observation distance is, oh, it's wide. Oh, sorry. Quite, Fresnel is actually finite. Sorry. The Fresnel used the finite distance actually. Fresnel used the finite distance. Fraunhofer used the infinite distance. So, in case of Fraunhofer diffraction, the slit can be placed infinite distance. In case of Fresnel, they place the source of light and screen should be finite. This is finite, this is infinite. Okay, very nice. 2 points are over. The next point is move in any direction of this slit action. You can move the object, which is source of light, or screen. So this is not a fix. You can move either side of the slit. Okay. Shift is possible in case of Fresnel diaphragm. In case of Fraunhofer, it's a fixed position. Finite distance, right? So infinite distance, they'll keep it actually uh, fixed position. Fixed position. So Fresnel diffraction pattern on a flat surface is assumed. The diffraction due to the Fresnel, it should appear on the flat surface. Fraunhofer diffraction pattern on a spherical surfaces. Oh, nice. The next two, uh, the changes as we propagate them further down downstream of the source of scattering. You have a downstream there. So shape and intensity of a Fraunhofer diffraction pattern stay constant. Here it's a constant, it's a kind of decreasing. So if they 4 marks question adugute, it's very simple. We use the cylindrical and planar. Here it's finite distance, here it's infinite distance. Move either side, fixed. Fresnel flat surface, spherical surface. Decreases, constant. So any doubts please, my dear students, my dear future scientists? Yes? Any doubts? Just keep in your brain. Oh, just 4 points or 5 points. In first case, if you use the cylindrical, then other case plane. Here it's we keep the finite distance panel. In other case infinite. Here it's movable. The other case fixed. Here you can see the flat surface, the images. Here you can see the spherical surface. Here decreasing, here it's constant. Is it okay?
Okay, sir.
I hope it's clear. Just keep in the brain because it's a compulsory question too, repeated question too. Okay, and there is one more difference if you would like to place it, diagrams. Suppose they ask long answer type questions, maybe you can put more information, but I don't think they ask it long answer. But competitive exam purpose, they may pick any point. So you can see the in terms of diagrams, parallel rays, Fraunhofer, Fresnel, you can see how they look like a cylindrical. Relation of Fresnel diffraction to Fraunhofer by a single slit. This is the in case of single slit. Okay. Okay, moving into I think this is over. And now I think this is another long answer question. I'm not going to discuss today. It's a long answer question. I'll tell your friends we're going to complete all questions soon. I mean tomorrow we're going to discuss at least one of the long answer. Okay, so we use circular aperture. Use the circular aperture. At first, we are going to focus the Fraunhofer diffraction. At the end, we go for the Fresnel. So, as we discussed, in case of Fraunhofer, we keep the source of light and screen should be infinite distance. So that is the second. We are going to use it, and in the first case of the Fraunhofer diffraction is single, which is a single slit, which is a circular aperture. Circular aperture and single slit also separate there. Single slit, which is actually cylindrical, like a square type. So here the next essay question we are going to do circular aperture. There we are going to get the condition for the maximum intensity and minimum intensity. Then we're going to for the single slit again to do the same thing, conditions for the maximum and minimum. Then after that we're going to double slit. Then after that grating. Then we're going to further. I made all slides because I took 2-3 days to work on this because I don't want to. Once I start, I'll just complete the stop chapter. So that's my policy. So I'm very much focused what I would like to do. So I've already prepared, completed this unit. Maybe two couple of hours required to make last two classes. Maybe one more class. I think I did all, but I think I have to Fresnel case. I have to make few more slides. So after this, I'm done actually. So once I complete this unit, I'll be free actually. One more unit is there. I'll take break. So after that, I'll take break, then conduct the exam. Then I'll wait for 1 week break. Then I'll continue class. Okay. Any doubts from today class? Jayalakshmi, Fatima, Mulya, Mushi, Ramesh. But you have to complete that exam also, guys. I'm going to consider that internal exam marks. So to send the university. So I don't care who will. I'll give the good marks for the people who are attending my classes. Even if they submit, even if they get full marks, 15 out of 15, I'll remove those marks because I don't know whether you copied or I mean how you attempted exam without attending classes. So definitely tell your friends, even if they got good marks, 15 out of 50 by copying somewhere or searching the question in the Google. I mean, you guys do that. I don't want that. I know some students are very much serious, very they don't even copy, they don't even ask the friends. So I'll definitely, I know, I can see the responses. So tell your friends seriously, they have to attempt the exam anyway, and they have to attend the classes too. So practical marks also we have to post definitely internal exams, attend regularly. So we have been working a lot to make the slides. You can see how we are making effectively to make effectively to type everything to type equations. It is not easy, right? So we have to understand and attend the classes. So thank you so much. Have a wonderful day. If you have any questions, I'll give the 2 minutes or 3 minutes. Please, it's your turn. I mean, you can share your ideas. Tell it. You can speak one by one. It's okay. I'm. Any questions from anyone? Please share. By the way, నేను అడిగేటప్పుడు అమూల్య ఎలా everything is fine?
Yes, sir. Fine.
Do you have any specific questions?
No, sir.
Everything is okay with you guys at home? No
Yes,
issues?
sir.
Right. Thank you.
No issue.
Right, great. I want you guys are safe at home. Don't go out and don't do jobs ఏదో డబ్బులు వస్తాయని చేసి అనవసరంగా don't get